Hi, okay, in this video we'll be doing electrical systems, electricity. Alright, so this is part of the upper block science. Let's jump into it. What is an electrical circuit made up of? Electrical circuit is made up of battery, bulb, wire, and switch. Let's look at this diagram to see what it looks like. So this is the battery. Alright, so battery. It is also known as a dry cell because it uses chemical energy. All right. So this is the wire. So this and these and these are the wires. This is the light bulb. All right. So there's the light bulb, and this item here is the switch, which controls the circuit to on or off. So what is the energy source in an electrical circuit? At primary 6 level, it's usually just battery, which will look like this. These are AA dry cells, or also known as AA batteries. Another common source of electricity or energy source is actually your mains electricity. So if you plug an electric item into your mains electricity, that would be your source of energy. So what actually flows through an electric circuit? The answer is electric current, which this is a dramatic picture of it. Basically, electric current flows in this wire through, if the wire is connected, through the wire to come down in this direction. So it flows in one direction, and that's your electric current. So next question, how do you know an electric circuit is closed? When the bulb lights up. So you will have batteries and you will have a bulb. So this bulb must light up. Then you know that it's all closed. Okay. And how do you know what is a closed circuit? It's that all parts connected and there are no gaps. So that means you have a battery over here. Right. So these two lines, by the way, stand for a battery. And all parts are connected to the battery, into the bulb. This is the bulb, and all parts are connected. There's no gap in this, so this is a closed circuit. All right. What are the characteristics of an open circuit? Some parts are not connected or have gaps. So let's say if I have a battery and I have a switch, and I have a bulb. All right, so this part is what I call the gap. All right, and that causes this to be an open circuit. Let's take a look at the next question. What is the purpose of a switch? It's to open or close the circuit. So let's say if I rub this away. So if this is an open circuit, and if I move this in this direction, then it will be a closed circuit. So I can then switch on or off my light bulb. Okay, let's move on to electrical conductors and insulators. Electrical conductors and insulators. So what are electrical conductors? Basically, they allow electric current to flow through it. These are some conductors. You have wires, you have gold, you have copper. This should be aluminium. All right. And what are some insulators? Insulators basically do not allow electric current to flow through it. You have plastic, you have wood, you have, this is what, paper, or this is paper, and this is plastic also. Yeah. So basically these things do not allow current to flow through, and this group allows current to flow through. So next question, wires are made of, so you need to remember these are copper. So wires are made of copper. And copper, iron, steel are electrical conductors. So most metals, gold, silver, most metals are also electrical conductors. Wood, plastic, rubber are electrical insulators. So there'll be questions asking you, oh, what should I use for the appliance handle? So appliance, handle. So the answer is wood, plastic, or rubber. Okay, so is a blown bulb an insulator or conductor? Why? It's an insulator because there's a gap in the bulb. Okay, I know I haven't taught you what is the concept of a blown bulb. Let's come back to this later. Okay, so now we're going to look at batteries. All right, the different kind of batteries. So the brightness of a bulb in a circuit depends on the amount of electrical current flowing through the bulb. So the more electrical current, the brighter the increase in brightness. All right, and likewise, the lesser the electrical current, the lesser the brightness. So how do you increase the electrical current in a circuit? You need to connect the batteries in series. So I'm going to draw for you how connecting in series looks like. Okay, so I've drawn for you the battery here and two batteries. So this is actually what connecting in series. This is connecting in series. All right, so this is the negative part of the battery. This is the positive part of the battery. You can see here. Then this is the negative part. This is the positive part. So negative to positive, that's in series. If you draw in the circuit diagram, it looks like this. All right, so this stands for the negative. This long stroke stands for the positive. You can also connect batteries in parallel, but you have not learned that in primary 6, so it's okay. Okay, so next question, what happens to a bulb when there's too much current flowing in the circuit? So if I connect a, oh no, not like that, if I connect a battery like that, like times 100 batteries, all right, and I connect that to a bulb, what is going to happen? It will melt, basically it will melt the filament and it will blow the bulb. Okay, so this is a picture of a bulb that I just drew. And usually there will be a filament that goes across the bulb like this, all right? But when there is too much current, what happens is that this filament will get so hot and melt, and then it will look like this. It will become like that, all right? So it will, this is what I call a blown bulb, all right? So usually there's a working filament, all right, and then this is a you can say it's a blown bulb, or you can say it's a you can say it's a melted filament. All right, so that's the melted filament right over here. Okay, so let's come back to this question. Is a blown bulb an insulator or a conductor? Why? All right, so a usual bulb looks like this. And if let's say there is a battery, a wire coming out, battery. So in a usual bulb, there is no gaps. All right, so the current moves from here to here, to go through here and come out and here. All right, so that's how the current moves. But let's say for a blown bulb, how would it look like? So this is a blown bulb. This is a bulb, and the filament is blown. So there is a gap in the circuit. All right, so come here. So my electricity will go from here to go in, and boom, it stops here. All right, because there is a gap, the electricity is not able to pass to this side, and that's why it stops here. All right, so that's why if you have a gap, then it becomes an insulator, because you prevent the electric charge from going across and completing the circuit. Okay, so next we are going to look at bulbs in series and parallel. So question, what is a series and what is a parallel circuit? Let's look at this picture over here. So a series circuit is basically there are two batteries and you have one bulb here followed by another bulb. So it's a 1, 2, 2 structure. But a parallel circuit, same thing, you have the batteries or dry cells here. The bulbs are not connected. Left and right is connected up and down. Okay, so another simple parallel circuit will also look like this. So you have a bulb, and then it will come back, and it will come back. So a series circuit is a left, right, but a parallel is up and down. All right, so I'm going to touch on what is the differences between the two circuits and why are we learning about it. So first thing is, for a series circuit, there's less current passing through each bulb. So what does that mean, right? So it doesn't matter. Just think of it as, you can think of it as you have 10 current over here. So after it passes through this bulb uses, let's say, 5 current. Okay, so it passes through this bulb, there is 5 current left, and then it passes through this bulb, there is 0 current left. So there was 10 current over here. Okay, just draw it again. So 10 current comes from the battery, 10 current, passes through the light bulb uses 5 current. So like this light bulb uses 5 current. So 5 current left. 5 current left. And then passes through this light bulb, also uses 5 current, now 0 current. Okay, so basically this light bulb gets 10 currents worth of electricity. This light bulb only gets 5 current worth of electricity. So this light bulb will be dimmer than this light bulb, all right? Now the question is, what happens if I have many light bulbs over here? Okay, many light bulbs. So if I have so many light bulbs, that means all these light bulbs will not be lighted up, all right, because there's already 0 current over here. There's no more electricity to give to these other light bulbs, so it won't be lighted up. All right, so that's the bad thing. There's lesser current passing through each bulb, lesser voltage. You get dimmer bulbs, or even bulbs that do not light up. So do not light up. All right, these bulbs do not light up because there's no more electricity or no more current for them. Okay, so now let's take a look at the parallel circuit over here. I'll be using my own one. Okay, so this is my circuit. Again, I have 10 currents worth of electricity coming down. All right, but interestingly, what happens in a parallel circuit is that this will remain as 10 currents and this will remain as 10 currents. All right, that's just the nature of electricity and how it works. So 10 currents will pass through this light bulb, then this will become 5 currents and it goes back. This will become 5. It uses 5 currents here. All right, uses 5 currents here, and then after that it will go back. Okay, but the key thing to note is that 10 currents will pass through each wire, and if I connect more light bulbs, I connect a lot more light bulbs, and so on and so forth. All right, what happens is that there will always be 10 currents. 10 currents going through. So all the bulbs will be the same brightness. Okay, the same brightness. That's good. And there's one more advantage which I will talk about it later, which is that if one bulb blows, so let's say this bulb blows, boom, all right, blow. So the other bulbs will still light up. So because the electricity can still travel through this wire down to this wire and go through this light bulb, so the other bulbs can still light up. But whereas for a series circuit, if this bulb blows, boom, there's no more bulb, this becomes a gap. and all the other bulbs here, all of them will not light up. Okay, so there are two main advantages. One of them is the same brightness for parallel circuits because it's all 10 currents. The other one is, well, if one bulb blows, the rest still lights up. Okay, and this is the opposite. They will get dimmer, it will get dimmer bulbs, and if one bulb blows, the rest will not light up. Okay, let's look at the questions. What happens when you connect bulbs in series? Less bright than just one bulb because each less electric currents flow through each bulb. All right. Hey, by the way, when I write like 5 currents going through here, 5 currents going through there, the bulb using 5 currents, it's all it's simplified for your explanation, but in real life you don't say 5 currents. Okay, you say 5 amperes, and it doesn't work so simply. I'm just writing this like 10 currents and it uses 5 currents just to simplify things for you to understand, but do not write this in your exams. Okay, this is just a simplification for your understanding. Do not write this current things in your exams. So what will happen if we keep adding bulbs in series to a circuit? The bulbs will not light up. All right, so I've shown you over here, the bulbs will not light up because there will be no more current for them. Draw a circuit with 2 bulbs connected in parallel. All right, so let's just draw it. So 2 bulbs, you should know how to draw it by now. So a battery, 2 bulbs in parallel, and you connect it like that. Okay, so that's draw a circuit. When bulbs are connected in parallel, the electric current flowing through the bulb remains the same. All right, so again, I say I have, where's my pen? I have 10 current going through, coming down. So this is still 10 currents. This is still 10 currents. Okay. All right. So electric current remains the same when you connect in parallel. So when you connect in parallel, the brightness remains the same because the current remains the same. Therefore, the brightness also remains the same because the brightness of a bulb depends on the current flowing through it. So when bulbs are connected in parallel, the circuit is still open or closed. When one bulb blows, it's closed because the electricity can, let's say this bulb is blown. So this bulb is blown. The electricity can still go from here. All right, it comes down here and it stops, but it can still go here, go through the bulb, come back and complete the circuit. Okay, so let's take a look at, this is a very common question. What are the advantages of parallel versus series circuit? So first thing is one bulb blows, the rest will still light up. That's the very big advantage for parallel circuit. So last time I remember, I used to have Christmas lights when I was a kid. So Christmas lights are, it connects to the main, all right? And then you will have a bulb, all the way for many bulbs. And I used to remember, right, if this one blows, the whole string will not light up. And then I have to go and individually see each bulb and find out which one was the one that blew. So then I can find, I can replace that bulb, then then the whole thing will light up again. All right, so that's really troublesome because it's very irritating when one bulb blows and the whole thing will not light up. So this is a very huge advantage. So can you imagine if your house is connected in series, if your house is your house lights are connected in series, and if one bulb is spoiled, then the whole house will be dark. Okay, that's quite scary, yeah? So right now, one bulb blows, it's just the bulb that blows, you just go and replace that bulb. Imagine if your toilet light blows, then the whole house have no light just because of the toilet light. Okay, so that's the disadvantage of series. The other one is same brightness, all right, same brightness for parallel circuits, so that's why it's also more advantageous. So question, same brightness, right? So if I put a battery here, I put a light bulb here, light bulb here, light bulb here. Theoretically, if I put them in parallel, they will have the same brightness. So can I put up to 1,000? No, might as well put 1,000,000 light bulbs and they'll have the same brightness. And then using one battery, I can light up the whole world. Is that correct? No, that's not correct. Because what happens if you put a lot of light bulbs, what happens is the time that it is lighted up will decrease as you increase the number of bulbs in the parallel circuit, and if the batteries don't change. Okay, brightness remain the same, but the time that they remain lighted up will decrease. The other thing is that parallel circuits are more troublesome to wire up, so disadvantages is that parallel circuits are more troublesome to wire. Series circuit really much easier, and then another one and then come back. So it's much easier, use lesser wires, cheaper. Parallel circuits are more expensive to wire, more complicated to wire as well. Okay, so let's look at this part, how to conserve electricity, switch off bulbs when not using. Use energy saving bulbs, also known as LED light bulbs. Should we put many plugs into one socket? No, because the plugs may get hot and start a fire. So this is what many bulbs in one socket looks like. So don't do this, all right, because it's called overloading and it has a very high risk of electric fires. Okay, so what material should appliance handles be made of? Plastic and wood. Why? Because they are insulators and they prevent the user from being electrocuted. Do not touch switches with wet hands, because wet hands, water is a better conductor. Water will help your skin conduct electricity better, so you get it is easier for you to get electrocuted. Alright, electrocuted. Check appliance for exposed wires. So exposed wires look like this. Alright, this is the exposed wire. So what happens when you have exposed wire? If you touch it, you will get electrocuted. If you don't touch it, if something else touch it, it will get burnt. So do you notice these black marks? These are the burnt marks, okay? And if you leave it there long enough, it will catch fire. That's very bad. So what can happen if electrical devices are not used safely? It can cause electric shocks and fires. Shocks to you, fires to the house. Both of them are not good.